generative AI is creating a lot more opportunities for all of us to build exciting applications. What I'd like to do is share with you some of the broad technology trends I'm seeing, as well as where that leads to building opportunities for all of us. AI is the new electricity. Starting about 100 years ago, electricity transformed every industry. And I think AI is bringing an equally big transformation. But a lot of work ahead of us is to identify and build the many things that AI has now made possible. I'd like to start off with describing what I'm seeing in the technology landscape, and this will lead into the discussion of some of the opportunities. There's a lot of buzz and excitement about AI, and I think a good way to think about AI is as a collection of tools. So the two most important tools in AI today are supervised learning, which is very good at labeling things, and then new entrant is generative AI, which can generate high quality media like text, images, and audio. And if you study AI, you may hear about other tools as well. But for today's purposes, I'm going to focus on what I think are the two most important, which are supervised learning and generative AI. So supervised learning, which started to work really well about a decade ago, is very good at mapping from input to outputs or from A to B. For example, if you input an email and have it output, is that spam or not? That's spam filtering. Or the most lucrative application of this that I've ever worked on is probably online advertising, where we input an ad and output how likely is someone to click this. And this moves for the large ad platforms, maybe more than $100 billion a year for a company like Google. Self-driving cars, input picture of what's in front of your car, label it with where are the other cars. For shipping, you can input a ship route, label it with the fuel consumed, and use that for logistics optimization. We also do a lot of work in manufacturing defect inspection. Input a picture of a phone, output, label that with is there a defect? Or for restaurant reviews, which is an example I'll dig into a little bit more today. Input a restaurant review and output is this a positive or negative sentiment for, say, reputation monitoring. This is what the workflow of supervised learning looks like. If you want to build a system for reputation monitoring for restaurant reviews, you would get a data set that maybe looks like this. Pastrami sandwich is great. That's the input. Label that as positive. Or service was slow. That would be a negative label. My favorite chicken curry, the positive label. And the typical process for supervised learning would be to get a label data set with both the inputs A and the outputs B, and then train an AI model on the data, and then find a way to deploy your model, maybe on the cloud service, so that you can then feed it a new review like best bubble tea I've ever had, and that would map to a positive sentiment. Over the last decade, I think the biggest trend in AI was large-scale supervised learning. What we found maybe 10, 15 years ago was if you were to build a small AI model, then even as you fed it more and more data, its performance would flatten out or plateau. It was as if the smaller AI models we were building back then didn't know what to do with all the data we could feed it. When I started and was leading the Google Brain team, the number one direction I gave the team was, let's just focus on building really, really large neural networks, or really, really large AI models. And it turns out that when you build a large AI model, the more data you can feed it, the better it performs. And this recipe of scaling up data size and the size of the AI model fortunately worked and drove a lot of progress over the last decade. But if that was the last decade, then I think this decade is turning out to be the decade of generative AI, which doesn't replace but adds to this recipe of supervised learning. So you've seen text generation where you can give it a prompt, and when you run the AI multiple times, it generates outputs like this, bagels with cream cheese, my mom's meatloaf, and so on. There's a lot of excitement about generative AI, so I want to take just half a slide to explain how this works, to maybe demystify this and also help strengthen the basis for you to build on this yourself. It turns out that generative AI is built using supervised learning, that input A to output B, to repeatedly predict the next word. So for example, if someone training a large language model, has read on the internet or found on the internet a sentence like, my favorite food is a bagel with cream cheese and lox, the sentence is then turned into a data set of inputs A and outputs B, where the system's trying to predict the next word. So if the input A is my favorite food is A, well, what's the right output the system should try to predict? In this case, is bagel. Or my favorite food is a bagel, what's the next word? Is with, and so on. And it turns out that when you train a very large AI system on a lot of data, hundreds of billions of words, or in some cases more than 1 trillion words, then you get a large language model like Llama or ChatGPT or some of the others. Obviously, I'm leaving out important technical details. We actually predict tokens, not words, and there's more to do to align these systems to make them more helpful, honest, and harmless. But at the core of the algorithms is using supervised learning to repeatedly predict the next word using a type of neural network called a transformer neural network. And it turns out that prompting is revolutionizing AI application development. Many of us will use these large language models as a consumer tool, where you go to a website, use an LLM to get our questions answered, or brainstorming companion or thought partner. But to me, I find at least as exciting, maybe even more exciting, the software applications we can build, not just the consumer tool, but the developer tool aspect of this. With supervised learning to build a, say, restaurant sentiment review system, this would have been the typical workflow that my teams may have used maybe a few years ago, which is to get labeled data might take a month, training AI model might take 3 months, then deploying a robust, commercial-grade AI system in the cloud might take us another 3 months. So it just took a while to use supervised learning to build these applications, but it was very valuable, so nothing wrong with that. But with prompt-based AI, I find that the workflow really changes. You can specify a prompt, maybe in minutes or hours, and then have it deployed to production in maybe hours or days. And this shortening of the development cycle is letting us prototype much more, try out many more ideas, and just build many more AI applications. So I want to show a quick demo of this workflow where here's a Jupyter notebook where I'm going to import some tools. I'm using OpenAI in this demo, but I often use Llama or other things in other applications as well. But I want to build a sentiment classifier. I can just write a prompt, classify the text below, delimit it by 3 dashes as having a positive or negative sentiment. So if you say, I don't know, I loved attending the Snowflake build event. All right, not sure what happened. Let's just run this, and it says, thank goodness, I got that right, positive sentiment. And this is all the code it now takes to build and deploy a sentiment classifier. So today, there are many applications that would have taken me and very good AI teams like 6 to 12 months to build that you can build in minutes or days. And this opens up the set of things we can now all do with AI. One of the things I've been working on has been having my team deeplearning.ai work with many industry experts to create online courses, many of which are just accessible online for free, for you to learn about more of these tools, to use these fantastic developer tools to build your own applications. And in light of these fantastic generative AI tools, let me say a little bit about what are the opportunities that lie ahead of us. So the size of these circles represents what I think is the value from different AI technologies today as measured by, say, end user revenue. Supervised learning for a single company like Google can be worth more than $100 billion a year. So it's massive, and there are millions of developers working on supervised learning applications. And generative AI is very exciting, but because it's so new, we still have a lot of work ahead of us to work out use cases. And looking ahead 3 years into the future, this is what I think it might grow into. Supervised learning maybe double in the next few years and go from really massive to even much more massive. And generative AI, starting smaller right now, will I think much more than double in the next 3 years because of the amount of investment and developer attention and just the number of people trying to figure out use cases. 3 years is an artificially short time horizon, and if it continues to compound at this rate for another 3 years, then maybe generative AI will even surpass supervised learning's value at some point. But I think that all of this light shaded region is that there's a lot of opportunities for new applications using generative AI or using supervised learning. And There's another trend I want to share with you that speaks to why AI maybe isn't more widely adopted yet. And this is the customization or the long tail problem. It turns out that if you were to take all current and potential AI projects and sort them in decreasing order of value, you get a curve that maybe looks like this, where to the left of the curve are the very valuable projects like online advertising or web search. And about 15 years ago, 10, 15 years ago, some of my friends and I had figured out a recipe to get these things built. Hire maybe 100 machine learning engineers, have a lot of people build one enormous, very valuable system like online ads, and apply that to a billion users, and this creates significant financial value. But the problem with this recipe is once you go outside consumer software internet, um, there are hardly any businesses with 100 million or a billion users you can apply one AI model to. Instead, these are some of the projects I've been working on and I'm excited about. We're working with a pizza maker, a factory, that needed to take pictures of the pizza to make sure that, say, the cheese is evenly spread. And this isn't $1 billion problem, it's maybe a $5 million problem. Or we're actually working with an agriculture company that did wheat harvesting. And it turns out that if you can figure out how tall the wheat is to chop it off at the right height, then you get more food off the field for the farmer to sell. And it's actually better for the environment. But this is another $5 million project, and you can't afford to hire 100 machine learning engineers to build a $5 million project. Or material grading, did a lot of cloth grading, sheet metal grading. And what I'm seeing is that whereas in the head of this curve, to the left, there are these billion or multi-billion dollar projects that we figured out how to build. And let's keep on building those. Over in the long tail, there are tens of thousands of $5 million projects that until recently has been very difficult to build and realize the value of. But the exciting trend is better tools is making it easier for all of us to build our own custom AI system. And specifically, low-code tools, maybe no-code as well, but I focus more on low-code myself, is making it much easier for you and others to customize your AI system. And the key technologies are prompting. We've seen text prompting. I'll talk about visual prompting later as well for processing images. And then also data-centric AI, which is this idea that rather than, say, asking the IT department of the pizza factory to write a lot of code in TensorFlow and PyTorch, which maybe they could do, is just tough. If we have tools to allow the IT department to focus on engineering and providing images, that could be a better recipe to set them up for success to build their own custom AI system for the pizza application. And by the way, the pictures of these pizzas, they don't exist on the internet. So, Google and Bing don't have access to these pictures, but data-centric AI is proving to be a recipe, in addition to prompting, to make these applications more feasible. And data-centric AI refers to the discipline of systematically entering your data to build a successful AI system. So one way to think about AI systems is code plus data, because you have to write code to train it on your data. And for a long time, the dominant paradigm in AI, certainly in research, was to download the data set off the internet and then work on the code or work on the algorithm. But because of this paradigm, I think for a lot of applications, there is some code implementation that works just fine. And so for many practical machine learning applications, I find that it's even more fruitful to just get a good implementation of a learning algorithm, do a robust tuning of it, but just get a good code implementation, and then spend your time focusing on getting the right data to the software. And this turns out to be a more efficient way to build a successful AI applications in a lot of cases. And I think yesterday and earlier today you've heard a lot about text prompting and the text revolution that is already here. I want to look with you a little bit further into the future. I think that the next wave will be in computer vision and processing images. So I hope you go build stuff with text today. Go do that. And if you want to be a little bit ahead of the next wave or ride the next wave that is just coming, I hope you also start to build things with image processing. What I want to do is actually go through a quick demo with you of maybe how easy it can be these days to build a computer vision application. I'm going to start by using supervised learning and then switch to generative AI to show you something called visual prompting. But some of my engineers and I we're on Zoom a lot, right, still, and we're actually wondering when I'm on Zoom, how often am I looking at the camera versus looking away? Because when I'm looking away, I don't see myself on my Zoom window, and I'm actually really curious. Like, do I look like I'm paying attention in the meeting most of the time, or do I look like I'm not paying attention? Um, and so Dylan, who's shown here in this picture, and I thought, well, let's throw together a computer vision application that can run on my laptop webcam and maybe monitor metrics to help me perform better on Zoom. So this is the landing lens platform, and I'd already uploaded 20 images of different people looking at the camera and looking away at the camera. And I want to show you, may surprise you how easy it is to build a computer vision application. So I'm going to turn on my webcam, and let's just take a picture of me looking at the camera. Look away. Let's take a picture. I'm just going to add, 2 images to my data set. All right, so I just uploaded 2 images, and then if I want to label it, I'm going to say facing the camera, and for this, I am facing away. And that's it. Now I have, so I had actually 20 images that I, previously put in here, but now I just uploaded 2 more. And if you hit the train button, then the code in this landing AI platform called Landing Lens will take all this data and build a machine learning model on it. When I demo this elsewhere, often people say, what, that's it? And that is actually how easy it is now to build a computer vision system where after uploading the data, hit train, finds a GPU, trains it. This is a learning curve. So the model is getting smarter and smarter. And then in a few seconds, it'll calculate the model performance and show how a model like this does. So if you want to build this type of face-focused demo yourself, or if you have an idea for some other application, or if you already have images, in your Snowflake data warehouse, think about whether or not you can tag images or get value out of your image data that you already have, or images that you may be able to acquire easily. So that's it. It's not perfect. Looks like it, missed 1 or 2 examples, but the speed of being able to do this lets us deploy things quite quickly as well. And it turns out that if I want to deploy a model like this, I'd actually previously, I really love Streamlit as a prototyping tool. So I'm going to run the Streamlit app that hooks up to a model that had trained a little bit earlier. And here I am facing the camera. And so the Streamlit app counts up, how often am I facing the camera? And if I face away, then it's recognizing me as facing away, and this yellow bar counting how often am I facing away is going up. And then if I don't know, look back at the camera, then hopefully this will recognize facing the camera. Well, there, all right. And now the purple bar is climbing again, right? And so I find that this workflow of using Landing Lens as well as a prototyping tool like Streamlit lets you build an application really easily. Whereas what I demoed just now used supervised learning, and maybe it takes hours or small numbers of days to build a computer vision prototype or application like that. I want to show you just one thing, looking even a little bit further into the future of how to speed that up even more using text prompting. We're going to take the idea of prompting from text to images. So using a neural network called a transformer network, we can now input a little bit of a pixel level input and use that to generate more pixel level inputs. So in this application, we are building a system to detect cracks. So given an image like this, we can label just a handful of pixels, and then using a transformer neural network and generative AI, generate outputs like these to quickly detect cracks. I want to show you how fast this is. So here's the Landing AI platform, and here's an image of a crack. And so I'm going to say that is a crack, and this stuff here is a background. Yeah, let me just label a little bit more of the crack stuff. Oh, that's pretty enough. All right. So the labeling took me, what, those like 5 seconds, 10 seconds. And then having, just like when you're prompting a large language model, you might type a little bit of text in seconds and then hit character return and then see what output it generates. So what I did was it just prompted this in a few seconds, and then I said run, and then this is the output that it generated. Kind of not bad, I think, right? Here are some of the images that I did not label, but it's learn to detect cracks on these different images, and there's actually no crack in this image. I'll just demo a different one really quickly. So today there are a lot of biologists, peering under a microscope slide to count cells, or these are actually cell colonies. You want to say that in purple is a cell colony, and I don't know, this stuff, this background, is not a cell colony on a slide, on a petri dish. And then just like when you prompt a large language model, you type your prompt and you hit enter. I just provided a visual prompt, which is labeling a few things on this image, and then run it. And then in seconds, is learn to detect cell colonies. And the result is not perfect. So if I want, I can continue the visual conversation where I can say, hey, you know what? I think you missed this one. So just like you can have a back and forth text conversation, I can have a back and forth visual conversation to say, I think you missed this, try again. And over time, really quickly, really hope the system learn to refine what it thinks. Oh, good, there. Now it looks much better, right? Still not perfect. We can keep on fixing it up, but I think it's actually not bad. Just as you can use text to prompt a large language model to build things in minutes, maybe, we're approaching a point where for some applications, not all, you can try to use a visual prompt to build some applications quite quickly as well. And why do I think the text revolution is coming to vision? So these are the trends I'm seeing. In 2017, the team I had once led, the Google Brain team, had published a research paper called the Transformer paper. And following that, led to tons of innovations by many groups building on top of each other, led to scaling up text models, things like GitHub Copilot and StructGPT, then eventually, GPT-3, GPT 3.5, ChatGPT, Google's Bard, Bing Chat, and so on. So many teams built on top of that to scale up transformer neural networks for text. What is not as widely known is that in 2020, about 3 years later, the same team, Google Brain, published a paper called the Vision Transformer paper. And since then, many teams, including mine, but also many others, I think Meta has also been doing a great job on this, but many teams have been building on top of each other with vision transformers. And I think the vision revolution is maybe a couple years behind the text processing revolution. But if you look at the breakthroughs that multiple teams are publishing in vision, I think that seems to me to be this next coming wave for the types of data, unstructured data we can now handle. And looking even a little bit further out, I want to share with you something I'm excited about, which is large vision models and specifically domain-specific foundation models. So one difference between the text revolution and the image revolution is that text on the internet sounds quite a lot like your corporate internal text documents because, human languages are human languages. Learn to read English or some other language on the internet, well, you can also read your corporate text documents. But what we've found is that images on the internet look quite different than the types of images most companies will have in their data warehouses. Because pictures of happy people smiling on Instagram, right? Fine, we have lots of pictures on Instagram and cat pictures and so on. But that actually tends to look pretty different than the pictures of cracks or pictures under petri dishes, which do exist in small quantities on the internet. Or pictures of pizza. You just don't post tens of thousands of pictures of pizza on the internet. And so what we found is that when we work with partners to take their proprietary images that look nothing like what's on the internet, we can often train a domain-specific foundation model that is adapted to the specific type of image data that they have. So I've seen, we've shown that, for example, if you train a domain-specific foundation model on semiconductor images, these images don't exist on the internet, then you can build a model that is well adapted to the types of features you want in order to, say, find defects on semiconductor wafers. Or for life sciences, we found that if we train a domain-specific foundation model just on, say, images of cells on a microscopic slide, say for histopathology or some healthcare application, then we get a model that is much better than ones trained on internet images of happy people smiling for the application of pathology or for life sciences or for healthcare. And so I think that looking even further out, one trend that I'm excited about and will be to take some of these amazing, valuable proprietary data sets that may already be sitting in your data warehouse to train domain-specific foundation models to get these large vision models that can be adapted to particular companies' unique types of applications. And I think that we're in the early days of seeing an explosion of applications in computer vision. It really feels to me this moment what text processing was like maybe a year before ChatGPT exploded onto the scene. But at Landing AI, we've been really thrilled with, and I've been personally really surprised at the diversity of applications, creative applications that people found. In agriculture, with tons of people working on applications like crop health, many groups working on e-commerce, shopping, environmental monitoring, a lot of geospatial imagery there as well. In healthcare, a lot of medical work with trying to find diseases in many different types of images, surprisingly many X-ray images, but also other types. Infrastructure, doing a lot of work of users on utility and power grid inspection, a lot of life sciences work. Showed one example just now. Tons of applications in manufacturing, especially quality inspection, but other things as well. Pharmaceutical applications, also physical brick and mortar retail applications like looking at shelves. But I've actually been surprised and delighted at when there are organizations either with images already in the data warehouse or with cameras out there, just the creativity that developers have been able to leverage in order to build all of these exciting applications. And so in terms of what's next, I hope that you will look at your images and videos stored in Snowflake and within your enterprise and see if you can extract value from the data that you already have. Either just for fun and for your own education or to build applications. I hope you also sign up for the Landing AI platform. Maybe go do something fun with it. And we also have an SDK that makes it pretty easy once you've trained a model to implement it, to integrate it with your app, with your own software for the workflow. And for a long time, I've actually had the deepest respect for a lot of the work that so many people in the Snowflake community are doing, because AI is code plus data, and having that data infrastructure creates so many opportunities for us to have software go to that data and mine and create value from it. And so I'm delighted to be here speaking with you today, and I really look forward to exploring closer partnerships and integrations with you and with the whole Snowflake community. Thank you very much.